Right. So hi, hello everyone. Name me Signakar sir. So last class we discussed the characteristics of DC motor. So now today we are going to discuss DC generator characteristics. Okay. So those who are in the live session, you can give a comment and share to your friends so that we can they can get the good knowledge of the subject. Okay. So now you can see this is ADDA247. Those who are not downloading the app, you can download the app in your mobile, ADDA247. So then these are the features of the app. So you will receive a current affairs, quizzes, daily quizzes, job alerts, subject-wide quizzes, and premium study materials, notes, articles, videos. Everything is available in the videos. Okay. So don't forget to download. You must and should download the ADDA247 app in your mobile. Okay. So then you can subscribe. So then you will get the latest notification what ADDA247 is doing, day-to-day activities. You will receive the messages. So as per that you can plan, or you can purchase, or you can purchase the live classes, or you can purchase the whatever the test series is. Everything that is available in the ADDA247. Okay. So today our topic is characteristics of DC generator. So those who are in the live, you must and should give a big like, okay, and share and subscribe the channel, so you will receive the latest updates. Okay. So now coming to the topic, characteristics of DC generator. So what are the main characteristics of DC generators as per the classification? So whatever the classifications are there in the machines. Okay, so we are going to discuss all the characteristics for DC motors. Okay, so mainly the classification of the DC motor are separately excited DC motor. Okay, so second one is self-excited DC motor. Okay, so this self-excited again divided into three types: series motors, another one is shunt motor. Okay, shunt motors, another one is compound motors. Okay, so these are the various types of DC generators. Okay, so mainly based on the field excitation, these generators are classified into two types: separately excited DC generator and self-excited DC generator. So further, these self-excited DC generators are classified into DC series generators, DC shunt generator, and DC compound generator. Okay. So what is the symbol of these generators and how we can draw the characteristics of generators. So while working these DC generators, so you will get the parameters, whatever the induced EMF, armature current, load current, line current, and terminal voltage. So all these parameters we will get from the operation. So after the operation, we need to estimate, we need to analyze the performance of the machine, we need to draw the characteristics. We need to draw the characteristics of each and every machine. Then only we can understand. So what is the, how is the performance of the DC generators, either series, shunt, compound, or separately excited. Okay. So coming to the characteristics of all these generators, so mainly these characteristics can be classified into three types. How many types? Three types. One is open circuit characteristics. So we can simply say OCC characteristics, open circuit characteristics, internal characteristics, last one is external characteristics. So these are the only three characteristics. For each and every machine we are going to draw these three characteristics: open circuit characteristics, internal characteristics, and external characteristics. Okay. So these characteristics of internal, external, and open circuit, so from which parameters we are going to consider to draw the characteristics, either open circuit or internal or external, that we want to know. Okay. So now you can see, coming to this open circuit characteristics of DC generator, so we are going to draw the characteristics between no load EMF, no load induced EMF versus field current. Okay. So for these parameters we are going to draw the open circuit characteristics. Okay. So sometimes in examination they will ask you, suppose in direct question, suppose, so the open circuit characteristics is drawn between, so the following is given, suppose E0 IF. Okay. So this is E0 and this is suppose IF. Okay. And E0, so if they give E0 IA, okay, so then E0, so ISE series, okay, and they'll give V into IF, they will give like this. Okay. So which one is the correct answer? So this first one is the correct answer. Okay. So the open circuit characteristics is drawn between E0 and IF. So this is the correct one. So this remaining will be wrong answer. So we need to identify this kind of observation. Okay. So now you can see next one is internal characteristics. So this internal characteristics also called as total characteristics of the generator. So internal parameters, what are the internal parameters when we are getting, so that we are going to draw the characteristics between that internal parameters. So you can see, so the internal characteristics curve shows the relation between no load generated EMF and the armature current. No load generated EMF is sometimes we can, so E0 IA, so are generated, sometimes we will going to represent EG. Okay. So whatever we are representing, you should continue with the ending up to the ending, so we can pronounce it at the same terminology. So that is very, very important. So next go for the external characteristics. Okay. So what are the external characteristics are there? So now you can see what are the external characteristics. So we are going to draw. So what are the external terminals? External means output current, output voltage, that is external parts. Okay, so we are going to draw the characteristics between terminal voltage and the load current. Okay, so that we are going to take, these are the parameters. We are going to draw the characteristics of a DC generator. Now you can see, so this is the general representation, internal and external characteristics of DC series and shunt motors. Okay, so now you can see, so what is open circuit characteristics, what is internal characteristics, what is external characteristics of DC series motor, DC shunt motor, DC series generator, DC shunt generator, and compound generator, and separately excited DC generators. Okay, so now you can see the symbol of the DC generator first. Okay, so characteristics of DC generator, you can see DC generator is made up of a constant prime mover. So under such conditions, the generator gives the relation among the excitation and terminal voltage and the load. Okay, so this relation gives the graphically, the curve is known as the characteristics. Okay, so the characteristics always represents the behavior of the machine. Okay, so under different load conditions. Okay, if I want to know the efficient, whether the device is efficient or not, I need to find. So then I need to conduct some experiment on the device. So here we are going to apply some different load conditions. We are going to identify the behavior of the machine, so that we can call it as a characteristics of the DC generators. Okay, so in this open circuit, already I told, so we are going to draw the characteristics of no load, okay, and the field current. Okay, so this at constant speed, known as a no load saturation curve. So it is shaped practically the same for all types of DC generator, whether the separately excited or self-excited. Okay, now you can see coming to the internal characteristics generally. Okay, so this is the graph representation between the generated EMF. Okay, so under loaded condition, so that will be less than the generated EMF at no load condition. Then load condition we are taking E, and no load condition we are taking this E0. You can identify this one. Okay, so as a result, this internal characteristics curve lies between the below the open circuit characteristics. Internal should be less than the open circuit characteristics. So we are going to consider, so here the graph is plotted between generated EMF at no load and the armature current. So why? Because the effect of armature reaction, the magnetic flux and load will be less. So endukanante, so due to the armature reaction. What is armature reaction? The effect of main field flux on the armature flux is called armature reaction. So because of this armature reaction, so the magnetic flux on load, the magnetic flux on load will be less than the flux at no load condition. Okay, so on load flux will be less than the no load condition. So at this condition, the EMF is generated at different load conditions. We are going to draw the characteristics between the terminal, whatever generated EMF versus the current. Okay, so this is the internal characteristics. Next, go for the external characteristics or load characteristics. These external characteristics also called as the load characteristics. Okay, so these characteristics is plot between terminal voltage and the load current. Okay, so manam the characteristic ikkada rasesam. So load current, this is the load current and this is the terminal voltage. We are going to draw the characteristics between the load current and terminal voltage. What about these internal characteristics? So it is a armature current versus, so this is the armature current versus, so this is a generated EMF. So we are going to draw the characteristics between, so this one. So what about this no open circuit characteristics? Open circuit characteristics is drawn between, so field current versus no load induced EMF at no load condition. So you can remember these are the x and y axis we are taking. So then we can analyze and how we will get the equation we can see. Okay, so for the external characteristics, so we are going to draw the characteristics between terminal voltage and the load current. Okay, so suppose the terminal voltage is less than the generated voltage. Okay, so terminal voltage is always less than the generated voltage. Induku why? Due to armature and series field copper losses. Okay, so due to armature losses, what is the IARA? So armature drop and series field copper drop. So due to that one, the terminal voltage is always less than the generated voltage. So for external characteristics, curve so lies between the internal characteristics of the DC generator. Okay, so and by an equal amount of voltage drop due to copper losses. Okay, so simply you can see what it is saying here. So open circuit characteristics is above, so then internal characteristics, then external characteristics. So in examination they will give you this curve like this. So which one of them they will give you A, B, C, D like this, A, B, and this one is B and this one is C, suppose. So what is the external characteristics for the given following curve? So they will ask you like that question. Okay, so if they ask you like that, we need to identify which A, either A are correct, B or C, we need to identify. So OCC curve is top, so that is the OCC curve, and the middle one is internal curve. So bottom one is, so it is very below the internal is external, so we need to identify like that. Okay, so these are the, so how these external characteristics we are going to get, you can see here. The external characteristics or load characteristics is plotted. External characteristics is also called as the load characteristics. So this can be plotted between the terminal voltage and the load current. Terminal voltage and the load current. So load current is, this is IL. Okay, and this is the terminal voltage. Means terminal voltage sometimes we will give represents VT also, so no need to confuse. This is the output. Okay. See here, suppose the terminal voltage is less than the generated voltage. Okay, then what will happen? So due to these losses, so whatever it armature is there, this field is there. So due to this one, the terminal voltage, this will be always less than generated voltage. Okay, so the curve, whatever the curve is external, that is below the internal curve. So now you can see from this one we need to identify. Okay, so for a DC, so this is the general representation. So how it is going to draw? So if we go for the DC series motor and DC shunt motor, okay, so definitely we will get. So now you can see same characteristics we are going to draw for DC series motor, DC shunt motor and DC series generator, DC shunt generator and DC compound generator. Okay, so now you can see for a DC series generator characteristics. Okay, so for a DC series generator characteristics, so this is the E0 no load condition. At no load condition, suppose if you are done any experiment in the laboratory, you can get some observation, you can get some knowledge in the practical. So definitely we need to identify, we need to keep on this here. Suppose I am going to draw this one, you can see DC series. This is the DC series generator. So we need to give this to the load. Okay, so this is the load between this terminal. So we are giving mechanical supply, mechanical input to this one. So this is the generator. Okay, so this is the field winding, this is the armature. Okay, so the field winding resistance is RAC. So this internal resistance is RA. So generated EMF at no load condition. So here suppose we are not applying any load, not applying no load. So no load. So we are not applying any load. Then what is the induced EMF in this one? So we can call it as the E0. E0. Okay. So then we can change this one. Then we can record this E0 values at different conditions. Okay. So at that time, so we will get this load current is increases, load is increases gradually up to certain rated value. Okay, so whatever the rated value you will get, so up to that we are going to increase the load. So we can take the record of this E0 and IL, then we need to plot graph between this load current and the no load induced EMF in the DC generator. So in this no load induced EMF is E0. Okay. So what is the equation you will get from here? So terminal voltage is, this is the V terminal voltage. So this is the line current. This is the line current. Okay. So generated EMF is at E0. E0 here in this induced EMF E0 is equal to, what equation you will get? IA into RA. So the current is delivering from this armature. So then you will get IA into RA. Okay. So then ISE into RAC. ISE into RAC. Okay. So plus terminal voltage is V. Okay. So the current is passing like this and coming back like this. Okay, so at no load condition, okay, so beginning the current will be 0. No load condition means the current will be 0. Okay, so even though the current is 0, so you will get some voltage, some EMF is induced, so in the armature. So at this point you can remember this is, so even though current is 0, so you are getting some voltage. Okay, so then we can gradually increase the load, so the load current will be increases. Okay, so then the generated EMF at no load condition also increases. So if you plot the graph, then you will get the curve like this. So this curve we can call it as a open circuit characteristics of a DC generator. Open circuit characteristics of a DC generator. So if you go for the any critical resistance, or if you want to draw the tangent, so we need to find the, okay, so there is a possibility to find the critical resistance of these conditions. Okay, so if you want to find the critical resistance, okay, so we must and should here, this is the open circuit characteristic, so we need to draw a tangent. Okay, so we need to identify, so at different instants. So here the voltage we need to record, so this is the E0, so this is the E0, and at the same time, so you need to find the field current IL. Okay, so then we need to find, if you want to find the resistance, you must and should take the difference between this one. So at this value, so this value minus this value, you will get the no load voltage, and you will get, this is the current. So then you will get the critical resistance of the curve. So this is the way we can find from the open circuit characteristics of a DC generator. Okay, so next go for the internal characteristics. So we are going to draw the internal characteristics between generated EMF versus load current. Okay, so those who are in the live, you can send this link to your friends, and share and subscribe also. Okay, so give me a comment, like and share, don't forget. So this is very helpful as also. So as per your convenient and requirement, we need to provide you good platform from ADDA247. Okay, so next coming to the internal characteristics. So internal characteristics is going to draw EG and IL. EG and IL. So for load current, this is the load current. So when this is the load current, okay, so we are going to talk about the DC series generator. So and this is the load current. So passing this one, load current is here for a series. Load current is equal to series field wind current is equal to armature current. All currents are equal. Armature current is equal to series field current is equal to and load current. Okay, so this is the load current. So all currents are equal because these are connected in series. Field line is connected in series with the armature. Okay, So then you will get the armature current here. Armature current is there. Okay, so here armature current is there and series field winding current is there. So this is the generated EMF in the generator, EG. Okay, so from this one you need to draw a characteristics between the generated EMF and IA. That IA must be is equal to ISC. The ISC must be is equal to IL. So all are same. Okay. So then the current will increases, the generated EMF is also increases. Okay. So why? Because so the field winding is connected in series. Here in this case you can observe the field winding is connected in series. Okay, then current increases, the flux is increases, then EMF induced is also increases. Okay, as per the Faraday's law of electromagnetic induction, so principle of DC generator. So when conductor cuts the flux lines, then EMF is induced. Okay, so the cutting of flux is more, then induced EMF is also more. Okay, so that is the generated EMF. Okay, so that current is increasing means current is more, then our induced EMF is also more. So like that we are going to take the values from this relation. So we need to draw a graph. So then you will get this curve is like this. Okay. So what will happen between this open circuit and internal characteristics? Okay. So the effect of main field flux and the armature flux, due to this armature reaction, so we are getting some gap between the OC curves and the internal characteristics, OCC and internal characteristics. If there is no armature reactions, so this must be equal to this one. So due to this armature reaction, so you are getting, so this generated EMF is less than the no load EMF. Okay. So next, coming to the external characteristics. So now you can see what are the external parameters are there. Terminal voltage V. So here this is the terminal voltage V and the load current IL. This is the load current IL. So we are going to draw the characteristics between the load current and the load voltage. Okay, so whatever the EMF is generated in the armature, that supplies current to this load. So that current is delivering from this armature is IA. Then it is call it as the IAC. That is passing through the load. We can call it as a load current. Okay. So for a series motor, all currents are equal, so that we are taking here IL, IAC, IL, IA, whatever it, so there will be no changes. But as per the characteristics, we need to draw a characteristics between load current and the no load voltage and generated voltage and terminal voltage. Okay. So next, terminal voltage. What is the terminal voltage here? Terminal voltage is V. So here from V is there here from, so we need to draw the characteristics between V and IA, or V and IAC, or V and IL, because all currents are equal. You can see here all currents are equal. Then IL must be equal to IA, that must be equal to ISC. Okay. So our aim is to draw the characteristics relation between terminal voltage V and load current IL. So instead of this IA and IAC, you need to substitute IL. So here IA is equal to IL, here IAC is equal to IL. So then what will happen? You will get, so then IA is common, IL is common, then you will get RA plus RAC. From that relation, IL is equal to EG minus V by RA plus RAC. Okay. So from that we need to draw a characteristics between V and IL. Okay. So then IL is increases, the terminal voltage will be decreases up to certain value. So up to saturation value it will be increases, then after it will be decreases. Even though the load is increases, the induced EMF, so up to rated value that will be increasing the voltage. So then after this saturation, then what will happen? So even the load is increases, the load current is also increases, then what will happen? The induced EMF will be decreases like this. Okay. So this is the external characteristics of a DC series generator. Okay. So this is the characteristics. These are the characteristics of DC series generator. So we are, for a DC series generator, we are going to draw the characteristics between load current and no load EMF. That is called as the open circuit characteristics, OCC curve. Next, for the operation in the running condition, so the EMF is generated, that is EG. So and the load current IL, we are going to draw the characteristics between these two parameters, then we can call it as the internal characteristics. So due to the armature reaction, so the generated EMF is less than the no load induced EMF. Okay. Next we can draw the characteristics between the load current and the output voltage, that is the terminal voltage. Okay. So due to the I square R losses, ohmic losses, so there is a huge gap between the internal curve and external curve. Okay. So the terminal voltage is less than, output voltage is less than the generated voltage due to the armature resistance drop. Okay. So this drop is IARA. So this is IARA. So due to this IARA, so the output voltage is less than the generated voltage. Okay. So these are the characteristics of DC series generator. Okay. So next we will discuss DC shunt generator characteristics. Okay. So those who are in the live, you can give a comment and you can give any suggestions you need to expect from my class. Okay. So now I am going to end the session. So remaining characteristics we will discuss next class. Okay. So thank you all. Thank you. సో ఎవరైతే ఎలక్ట్రికల్ జేఈ ప్రిపేర్ అవుతున్నారో, ఓకే, సో అడ్డా 247 అనేది మనకు సౌత్ ఇండియాలోనే ఫస్ట్ లైవ్ క్లాసెస్ అనేది స్టార్ట్ చేసింది. సో మీరు ఎవరైనా ఇంట్రెస్ట్ ఉండి అడ్డా 247లో జాయిన్ కావాలనుకుంటే లైవ్ క్లాసెస్, సో అలా కంప్లీట్ సిలబస్, ప్రీవియస్ క్వశ్చన్ పేపర్ డిస్కషన్స్, ఎక్స్పెక్టెడ్ క్వశ్చన్ డిస్కషన్స్ ఉంటుంది. సో మీరు ఒకవేళ ట్రై చేయొచ్చు. ADDA247.comలోకి వెళ్ళండి. ఓకే. సో అందులో స్టేట్స్ అండ్ సెంట్రల్ అని ఉంటుంది. స్టేట్స్ ఎలెక్ట్ చేసుకుంటే మనం ఏపీ, తెలంగాణ అని ఉంటుంది. సో అందులో మనం SSC JE అని ఉంటుంది. సో మీరు అది లైవ్ క్లాసెస్ పర్చేజ్ చేయొచ్చు, టెస్ట్ సిరీస్ కూడా పర్చేజ్ చేయొచ్చు. ఒకవేళ మీరు లైవ్ క్లాసెస్ కనుక పర్చేజ్ చేయాలి అనుకుంటే మాత్రం సో మీకు అది బెస్ట్ ఆఫర్లో ఈరోజు ఇస్తున్నాం. ఓకే. సో అది కేవలం 1949 రూపీస్కే వస్తుంది. జనరల్గా అయితే 2350 రూపీస్ ఉంటుంది. ఓకే, సో ఇది మీ ఫ్రెండ్స్కి కానీ షేర్ చేయండి, ఎవరికైనా యూస్ఫుల్ అవుతుంది. ఒకవేళ మీరు నిజంగా లైవ్ క్లాసెస్ జాయిన్ కావాలి అనుకుంటే మాత్రం, ఇఫ్ యూ వాంట్ టు జాయిన్ ఫర్ ఏ లైవ్ సెషన్, ఓకే, సో you must and go for the ADDA247.com and you can purchase. Okay, so already live classes batch అనేది స్టార్ట్ అయిపోయింది. ఓకే, సో still students are joining. Okay, so 10th of this month only started. So if you join now also, so we will cover all the remaining syllabus also. Okay, so thank you all, thank you, don't forget. సో ఇది మీరు షేర్ చేయండి, లైక్ చేయండి, ఛానల్ సబ్స్క్రైబ్ చేయండి. ఓకే, సో ఎవరికైతే యూస్ఫుల్, డిజర్వ్ క్యాండిడేట్ ఎవరైతే ఉంటారో వాళ్ళకి యూస్ఫుల్ అవుతుంది కాబట్టి మీరు మస్ట్ అండ్ షుడ్ దీన్ని షేర్